All right, so let's talk about making your own dependency injection library. So DIY, dependency injection, YOLO. The goal is not for you for everybody or every team to make a dependency injection library. The goal is for us to be able to understand how the hell these black magic libraries work. So I'm going to start with a very simple class. I have a visit handler class. And all it's doing is you can visit, and it's going to increment a counter, and it's going to log to a logger the number of visits. So then I have, so this needs a counter and a logger, right? So I have a counter class that counts and a logger class that logs to a print stream. Pretty simple. That's cool. So how do you normally, without dependency injection, any dependency injection library, how do you do that? You create a counter, you create a logger, the logger needs a print stream. We're going to use system.out in that case, and then you create a visit handler from that. So this is basically manual dependency injection, and then you can visit. But let's focus on this. So this is very simple code, but in your big apps you have a lot of things to set up, and one of the core problems is the ordering. Which should I create first? When should I create it? And that's a problem that dependency injection libraries usually solve. So how does that work? What usually happens is you create an object graph, and then you ask the object graph for an instance. So what's an object graph? It has different names depending on when you started writing Java. It used to be called a container in Spring, and then an injector in Juice, and in Dagger we call that an object graph. But it's really some sort of factory. It's something that can create instances and also retain instances. So I get an instance, and then I can use it. So the basic signature of that object graph is, give me a key, I'm going to give you an instance. And the way we generally approach that is we usually use types, so class literals as keys. It could be a strings. It used to be strings in Spring, but generally it's a class. Okay. So to build an object graph, what do you need? It basically boils down to two classes. You need factory, which is an interface. A factory is something that can create instances for a given key. And then the linker. And what's a linker? A linker is essentially a map of keys to factories. It's the thing that holds everything together. So every time you ask a factory for a given key, create me an instance, the factory is going to create that instance, but it might need other dependencies, and it's going to rely on the linker to get those other dependencies. So you can see that the linker, you can install factories, which is basically you put something in the map, you associate a key to a factory, and then you can get a factory. This is super simple. Well, with that, we have dependency injection, a dependency injection library. It's not going to be pretty, but we have it. So the object graph then is pretty simple. I have my linker, I just ask for the factory because that corresponds to that key, and then I ask that factory for an instance, and I pass it the linker, and the factory is going to find the dependency that it needs. All right, so let's go back to the main. So we had this build object graph method. What does it look like? Well, I create a linker, put a bunch of factories in there, and I return an object graph. So that's the interesting part. What does it mean to install a bunch of factories? Well, so these are anonymous classes. You see that I do linker.install, I pass it a key, which is visit handler. So anytime you want a visit handler, call into this factory. And then the factory gets a counter factory, gets the logger factory, gets an instance of each of those, and then creates a visit handler and return it. All right. Well, same thing for the logger. You have pretty much the same thing. Gets the print stream factory, creates the logger. Cool. Now the print stream, well, same thing, except we don't create an instance, we just always associate it to system.out, where we're going to print. So this is interesting, but it's a bit of boilerplate, so could we simplify this? Well, we're going to create a class called value factory that's just going to always return the same value, so that's what it would look like. Again, pretty simple, just create an instance and I'll always return the same value. And yeah, too many animations. And then we have this counter that always create a new instance, but actually we want the counter to be a singleton. We always want the same counter to be shared across the system. So we're going to create a simple singleton factory class that's going to wrap a factory, and it's going to basically it's going to delegate to a factory, but the first time it's going to delegate to it, and then it's going to keep the instance around and keep returning that same instance. So with all these things, that basically means we now need to update our linker to what am I doing? I think I can have my presenter notes, so I don't know what I'm talking about right now. Anyway, So our linker has essentially two methods, as we saw. And yeah, sorry. And what we want to do now is understand what the hell happens. So we add a log saying, okay, I'm going to, every time I ask the linker for a factory, I'm going to log it, all right? And so we look at what happens. And when I get a visit handler, then that's the output, which is I asked for a visit handler, which needed a counter, which needed a logger, and it also needed a logger, and then the logger needed a print stream, all right? So we have dependency injection in like 20 lines of code. And so what happens when we ask for two visit handlers? Like I'm like, I want an instance, and like I want another instance now. Well, it's going to do that twice, right? It's going to reach out and then come back and then reach in and come back again. It's kind of a waste of time, and we can do better, right? So let's look at that factory interface. So there are basically two things happening in the factory every single time. First of all, get all the factories. Second of all, get the instances from the factories. So if we separate these two, then we can do the get all the factories part once, and then every time we need an instance, we can get the dependencies we need. So that's what we're going to do. We're going to have a link method that's going to take the linker, which remember is just a hash map of keys to factories, and we're going to have the get method that's going to create the instances. So if we go look at that linker, that's the old one. We had this factory. You can put a bunch of keys and factories in there, and then we have the way to get them. So now we keep that part where we just put the factories, but we have two kind of maps. We have the ones we installed and the ones that are linked, the one that have their factory dependencies resolved. So these are the linked factories. And so here what happens is, okay, I'm asking for a key. Do I have it in the linked factory? Yes, no. Well, if I don't, then I'm going to get it from the non-linked factory. I'm going to link it, which is basically the time where we get the dependencies, and then I'm going to put it back in that map. All right, so what does that change? This is what it was before, and this is what it becomes. So we have two methods, link, where we extract the factories and store them, and then get, where we create the instances. So let's come back here and add some logs to figure out what the hell happens again. So when we ask for a factory, we log it. When we link it, we log it as well. So now you can see we asked for the visit handler twice. The first time we got all the factories. The second time its instance is faster and it's better. All right, so again, it's probably like we're at 10 minutes in, and we had a sort of optimized dependency injection library. However, this is our configuration, and this is shitty. Like, who wants to write or read that kind of code? Really, it's really bad. So, and this is like the rest of it, really bad. Let's come back to our linker. So like there's the linking part, but really the interesting part is where we find the factory that corresponds to a key, right? So let's put that in the method, load factory, and then let's isolate that, so it's still the same thing. If we can't find the factory, we throw an exception. It's basically an incomplete graph. All right. So let's come back to our visit handler. And it's time to bring @inject, the magical annotation that everybody loves. So what does that do? It doesn't do anything, right? An annotation is just that. Annotation is metadata. However, what we're doing here is we're clarifying our intent, saying, well, we expect the visit handler to be created by our dependency injection library. So if we come back to that load factory method, we're going to add a little bit of code. We're going to say, well, okay, if I haven't set any manual factory for this, then I'm going to take that key, which is a class, and I'm going to try to find a constructor with @inject on it. If I find one, then I'm going to create a reflective factory. You can also notice that if this class is annotated with @singleton, I'm going to wrap that factory in a singleton factory. All right? I'm saying factory a lot. I hope you like that word. What's @inject? What's this method? It's pretty simple. I ask the class for the constructors, look for one that's annotated with @inject, then I return it. All right? Super easy. So coming back to, let's look at the reflective factory. What does it do? Again, super simple. When I want a link, when I want to find all the dependencies for a given factory, all I have to do is to look at the parameter types of the constructor of the class and ask for a factory for each of those parameter types. Put that in a list, and then when I want to create an instance, I just need to call each of the factory in order, get the corresponding object, and then use reflection to call that constructor. So here, it's a very simplified version of Juice that we just built in 20 minutes or something. And so that's what we end up with, right? That's our configuration. It's just one line now. We're just saying, okay, well, when you want mainstream, you're gonna actually, use system.out. Cool. So it's not magic anymore. The problem with Juice is it's using reflection to figure out the dependencies that you need, and then it's using reflection to create instances. And that can be slow, and so we want to go faster. So let's come back to our original example of how we created anonymous classes for factories to set up things. Basically, we manually wrote those factories. This is an anonymous class. What if we were to generate it instead? So instead of that anonymous class, we just create a real class, and we take the name of the dependency. We add $factory behind it, and we do exactly the same as we were doing before. Now let's say that we have something that can generate that. For example, an annotation processor in Java. It could be something else. Now we can use that, right? So one thing though, how do we support singleton here? Well, we're going to create a superclass that has a boolean, am I a singleton factory? And then we're going to store that by passing it to the constructor. Remember, this is all, at compile time, we can look at these singleton annotation and decide whether this is going to be true or false, and whether we're going to, this is going to be singleton factory or not. All right. And so finally, at runtime, how do we find that factory? Well, I asked for a key, and the factory is the same class with $factory at the end. So we just concatenate the two, and then if the singleton boolean is true, we wrap it with singleton factory, and we return it. We just load that class. Again, super simple. All right. So if we come back to our load factory, this is basically what we do. We try to find a corresponding generated factory, of course, mapping to the key. So what we actually have here is, let me go back for a second. This is Dagger 0.5. It's not Dagger 1. It's missing a key part of Dagger 1, but it's the performance improvements that Dagger was bringing over Juice are here. This is exactly what it's doing. Now, let's look at another class. I wrote a database manager class. It needs a database, and it's going to execute some interesting code. Now, when I try to run that code, so I build the object graph and I ask for a database manager, what I'm going to get is an exception saying, hey, I don't know about database. Like, where is this database coming from, right? And the problem is maybe I'm writing a server, and maybe a database manager is used like once every 360 days. I don't know, and so it's going to crash way later. What I really want to do is crash as soon as possible. So how about crashing on startup, right? Like tell me when something is not going to be, I can't resolve it. So how do we do that? Well, let's introduce a validate method where you pass a type, and it's going to tell you, sure, I can do that, or it's going to throw an exception if it can't. And how do you implement that? Super simple. Again, our linker will throw an exception if you ask for a factory. So the interesting part here is we're actually never creating the database manager instance. We're just looking for its factory, and if it's not there, it's going to crash. All right. So we have basically runtime validation, and that's it. So to be continued. I don't have time to go as much as I would like to go. But the interesting part is we just saw runtime validation. To get from Dagger 0.5 to Dagger 1, what we need to do is compile time validation, which means this validate and give me a type to validate. This is basically what Dagger 1 has. You have a place where you define the types that are going to be asked at runtime, and then Dagger looks at the whole graph of dependencies. The only problem here is that we saw where we were binding print stream to system.out. This is like code that an annotation processor can't see, so we need to switch how this is done by using provider methods in Dagger. So if you've used Dagger and you've seen these like add module annotations with injects on it, inject is basically the whole point of injects is to do this validate thing. The Dagger 2 gets rid of the linker and just generates a linker class for every single object graph, or it generates an object graph class. It's kind of merging them together. And then we haven't talked about scopes and hierarchies, and that's all I had because yeah, it's 15 minutes. I'm happy to take any questions. That's it.